Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, welcome to lesson 26. This is Triangle Congruency Proofs. And in problem number 1 here, I've already color-coded what we're trying to prove. Okay, so it's really important that you, when you look at a proof like this, go right to the bottom and see what our goal is. So after color coding these, I'm now going to move them out of the way so we can see the whole diagram and then the exploded diagram. So this is our goal. We are trying to prove triangle BEA, which is B-A-E, B-E-A. So here's B, here's E, and here is A. We're trying to prove this red triangle is congruent to CED, which is the blue triangle. Okay, so there's our goal. Proving this triangle congruent to this triangle, and it is in this diagram. Okay, so after doing that, we're going to jump to the first given. And it says side AB is perpendicular to BC. Okay, and then I'm going to label the diagram. So AB is perpendicular to BC. That tells me that that is a right angle. They're also saying that BC is perpendicular to DC. Well, if BC is this segment here and DC is this one and they're perpendicular, then this is a right angle. Okay, and that is given. So before I go on to the next given, let's just focus on what this will lead us into in this proof. So now I can say that angle ABC is 90 degrees. So I can say the measure of angle ABC equals 90 degrees. I can also say that the measure of angle DCB is 90 degrees. Okay, and the reason is definition of perpendicular lines. Okay, since they're perpendicular, they form right angles. Okay, so now from that, well, if ABC is 90 and DCB is 90, then now I can say the measure of angle ABC is congruent, or equal, I should say. When we talk about measures, we don't say congruent. The angle is congruent, the measures are equal. The measure of angle ABC is equal to the measure of angle DCB. And that is definition of right angles. Or not, I'm sorry, transitive property. If A equals B and B equals C, then A equals C, transitive. Okay, so now I know they're congruent. So in my new diagram, well, the whole thing isn't there, so we still haven't been able to mark anything here yet. All right, so that's done. Now what else can we do? We have to go on to our next given now, so let's switch colors. So now we're going to do DB bisects angle ABC. And I'm also going to say that AC bisects angle DCB. Okay, so if DB bisects this, then this angle is equal to this angle. If AC bisects DCB, then it cuts it into two congruent pieces. So this is congruent to this. And the reason, that is the definition of angle bisector. Okay. Still with me here? Bisector cut the 90-degree angle into two congruent pieces. Well, if that's the case, then this is 45 degrees, and this is 45 degrees, and this is 45 degrees, and this is 45 degrees. So this is 45 degrees, and this is 45 degrees. So that means this is congruent to that, and that is an angle. I'll mark it on the blue one. Okay, we're leading up to angle, side, angle, 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 side, or side, 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 one of those statements. So we have an angle so far, so now we know it's not going to be side, side, side. And now I can state, I've already put it in here, so now I need to say it in my proof. The measure of angle ABE equals 45 degrees. Comma, the measure of angle DCE equals 45 degrees. And the reason for that, same for both, definition of angle bisector. Okay, I made a mistake here, DB and AC, that's not definition of angle bisector, so I can fix this real quickly. Unfortunately, if you copy this, you can't, I'm sorry. This goes down like that, and this was a given. Hopefully you caught that and wrote given instead of what I wrote. Okay, so DBC and being an angle bisector to ABC and AC bisects DCB is a given. It was right here. And then from that, we can say the angles are 45 degrees, and that is the definition of an angle bisector. Okay, so that's that. So let's move on to the next given. EB equals EC. Given. Mark it. I'm going to mark it here because marking it here makes it, well, I can, I guess. Makes it a little confusing though because it's not the whole length. It's BE is congruent to EC, and that's a side, by the way. So now we have an angle and a side. Let me put an A over here. Let's make them all the same color. So we have an angle, we have a side. Okay, so that was given. All right, so now I can see, now I'm focusing on these up here. Now I'm done with this diagram. Now I can see that angle AEB is equal to angle DEC. Okay, vertical angles. Vertical angles are congruent. So that means this angle is congruent to this angle, and that is an angle. So we're done. Now I can say what we're trying to prove. Triangle BEA is congruent to triangle CED. Reason, A, included side, A. And that is this proof. Okay, number 2. All right, again, I'm going to start saying this more as I go on. Always look at what we're trying to prove before anything else. What are we trying to prove? We're trying to prove two triangles congruent. So I outlined one of them. Triangle ACE is this red triangle, and let me move it out of the way now. And this might help you in figuring out what you're trying to do and seeing it if you pull the angles or the triangles out. So there's triangle ACE that I drew over top of the diagram and then moved it. Okay, so if you have patty paper, this is what you could do. And then this one, we're trying to prove that this is congruent, triangle ABF. So if I put that back, that's ABF. So looking at this, it doesn't look like it's congruent, but if I rotate it and flip it, then we see what's going on now. So it's supposed to be closer than that, but you get the idea. So it's supposed to be a rotated flip triangle. Okay, so that's what we're trying to prove. All right, so let me just move that back down now. So this is, why does that keep exploding? Let's move this to here. And I'm going to label this triangle so we can keep track of what angle's what. So here's angle A right here. Here's angle F. And here's B. So we're trying to prove these two triangles are congruent. Given side BF is perpendicular to AC and CE is perpendicular to AB. So let me use green. BF perpendicular to AC. So that would make this a right angle. So angle BFA is 90 degrees. And I'll mark it in my diagram that I pulled away. CE is perpendicular to AB. So that would be this angle here, angle AEC, or simply E on my red triangle. So there is an angle and there is an angle. Okay, so with right triangles, we could do ASA, or we could do angle, angle, side, or we could do hypotenuse, leg. So we don't know yet what this one's going to generate, but we do know that this was a given, so we label our reason given. Okay, all right, so there's that. And then what we're going to do is state that these angles are 90 degrees. So what we do is we now say the measure of angle AEC equals 90 degrees, and the measure of angle AFB equals 90 degrees. And that is the definition of perpendicular bisector, or perpendicular, definition of perpendicular. It's not a bisector, just perpendicular. So that's the definition of perpendicular lines. They form right angles. Okay, so now I want to go on to my next given. AE equals AF. That was a given. And I'm going to label my diagram. AE, just this piece is congruent to AF. And when I say AF, it's not the whole side AC, it's just this AF, and that is right here. Okay, so now we have an angle and we have a side, or we have a 90-degree angle and a leg. So we're still not sure what we're going to do with these. All right, so next thing. They are right angles. And we have an angle A right here in both triangles. So angle A is congruent to itself. So the measure of angle A equals the measure of angle A. And the reason is reflexive property. Okay, and so this is a side and this is an angle, and the side's included between two angles. So we have an angle, we have a side, we have an angle, and now we can see that that is spelling it out for us. It's right there in front of us. That's angle, side, angle. So now we can say the triangles are congruent. So triangle ACE is congruent to triangle ABF by angle, side, angle. Okay, page 2 brings us to exercise number 3, another proof. Okay, so let me discuss something again. Always write your table, statement, reason. So it's a 2-part proof. And always look at what you're trying to prove first. We're trying to prove in this one that JY, this segment here, is equal to KX. Okay. So there's two things going on here. We got these little triangles here. We've got the bigger triangles as well. So let's see what's going to happen. So I'm going to explode this up a couple different ways. And I'm just going to bring the pieces down like so first, and then I'm going to label them and we'll see what happens. So what did I just slide down? This was JXZ. So this is JXZ, and this is KYZ. K, this is Y, and that is Z. Okay, and then there are other triangles here as well. So let me highlight those and I'll be right back. Okay, so then I've highlighted these two triangles right here. So this is JYP. So let me bring that down and label it. Okay, and then I will grab this triangle, and that is KXP. I'll put this right here. So this is K. Okay. So this was K right here. Over to X here, and P's down here. Okay, so I've exploded this two different ways. There's a whole bunch of stuff going on here, but hopefully this makes it clearer when we're doing this. And now I'm going to look at my givens. So what are we trying to prove? What we are trying to prove is JY. This is congruent to this. Okay, that's the goal. So we have XJ equals YK. And I'm going to label my diagram. XJ is just this short piece right here. It's congruent to YK, which is right here. So that's this little triangle right here. Those sides are congruent. I'm just going to continue, and I'm going to say also PX equals PY and label those. So PX is this piece and PY is this piece. PX is this piece, PY is this piece. But PX plus XJ is equal to PY plus YK because congruent pieces add up to congruent totals. And we'll get to that in a minute. So anyway, these two are givens. Okay, and then now we're going to look at the angle, the measure of angle Z, X, J equals the measure of angle Z, Y, K. Z, X, J is right here. So it's in this little triangle here. And that's congruent to ZYK, which is right here, ZYK. So we're looking at the little triangle now. Now we have a side and an angle in the little triangle, and we have a side in the bigger triangle. Okay, so progress. And that's all from the givens. Okay, so now that we've done that, we can state what I just said before. Since JX is congruent to KY and XP is congruent to YP, then the total, the sum of the two. So if this was side 1 and this is side 2 and this is side 3 and side 4, 1 plus 2 equals the 3 plus 4 sides, okay? Because congruent parts added up equal congruent totals. So now I can say JP equals KP. Okay, or they're congruent, I should say. If they're equal, I'd have to put the bar over top. The measure of JP, the length of JP is equal to the length of KP. JP is congruent to KP. Reason, segment addition. Adding congruent segments will give you congruent sums. Okay? So now I said JK is equal to, or JP is this side, is congruent to KP. So in this triangle, I have angle side so far. Remember, you need 3. And in this one, I have side side. And I need the included angle, P. Oh, Okay. The measure of angle JZX is equal to the measure of angle KYZ was what? Given? ZYK. JP is equal to KP. Okay, here we go. So now I can say the measure of angle JZK. I'm sorry, JZX. Oh, I see now. Yep, just jumped out at me. The measure of angle JZX equals the measure. So here's JZX is congruent to or equal to the measure of angle KZY because they're vertical. Vertical angles are congruent. So let me label that. I'll use 2 marks. And I'll use 2 marks. So that is angle JZX. JZX is in this little triangle. So is equal to KZY. That's right there. Okay, because vertical angles are congruent. They are vertical. And now I can say the triangles are congruent, the little ones. So now I can say triangle JZX is congruent to triangle KZY by angle side angle. Okay, so those 2 triangles are congruent. Great. We're trying to prove JY. We now know JZ is congruent to ZK. Okay, because of corresponding parts. But before we get to that, see, we're trying to look at other things now. And now I can, oh, I see. Now I can prove that this angle, J, is congruent to angle K. But I don't want to just call it J and K because it's in this big diagram. Well, I guess I could because there's nothing else in the big one either. So angle J equals angle K. And its corresponding angles of congruent triangles are congruent. And I just call that corresponding parts because an angle is a part. Corresponding parts of, can't talk and write at the same time. Corresponding parts of congruent triangles are congruent. Okay. All right. So now I have those triangles, all that. So now I can label this diagram up here. I know that angle is congruent to that angle. Oh, guess what? That's in this triangle. Okay, but it's not included. There is no such thing as SSA. We cannot do that, so we aren't done. But we can now say angle P is congruent to itself. So now I can say angle P is congruent to angle P. Angle P is right here in the diagram. Those overlapped right there. Let me use 4 marks here because I've used 1, 2, 3, and now I'm on my 4th angle. Angle P is congruent to itself. So when I drag this out, this angle is congruent to 1, 2, 3, 4. That angle. Angle P is congruent to itself. That's reflexive. Okay, and now looking at this diagram, I didn't need J equal to K. That didn't help, but now I have an included angle, side, angle, side. So now I can say triangle PYJ is congruent to triangle PXK. Reason, SAS. So now I know these triangles are congruent. And I'm trying to prove JY, this piece here, JY is congruent to KX. So now that the triangles are congruent, I can now say JY is congruent to JX. So JY is congruent to JX. Reason? Corresponding parts of congruent triangles congruent. These two triangles are congruent, therefore all of their corresponding parts are. So this is congruent to that. No. JY is congruent to, not JX. There's a miss, yeah. See, you always should pay attention to what you're doing. I didn't see a JX here, so I questioned it. I wrote it down wrong. It's KX. Okay. JY is congruent to KX. Corresponding parts congruent. Triangles congruent. So saying they're congruent, we can now say that JY, the measure of JY, equals KX. Reason, definition of congruent. Okay, if something's congruent, it's got the same length. If two segments are congruent, they have the same length. Okay, here's problem number 4. And let's see, we have triangle JKL. And there it is. And triangle XYL. Okay. So we're trying to prove XY equals XL. XY equals XL. So again, I've exploded this diagram. I'm going to move this triangle here. Actually, let me put it right here, and I'll put this one down here just in case my reasons are lengthy and I don't want to write over my diagram. Okay, so this was J, K, L. This is X, Y, L. We want to prove XY is congruent to XL. So they share L. So these are the things that I look at first. So I see that angle L is shared. So I'll mark that. So there's a reflexive property going on there. There's nothing wrong with looking at the big picture and saying, okay, what do I know just by looking at this? What's congruent to what, and that kind of thing. So first we're going to now try to prove that this is an isosceles triangle, right? Because if XY is congruent to XL, then we have an isosceles triangle. Let's see. So first off, it says JK equals JL. That's a given. Let me label it. JK is equal to this whole side, JL, not just XL. All right. So JK is congruent to XL, or JL, I mean. JK equals JL. So there it is in the diagram that I pulled out. The bigger triangle's red, and so those two sides are congruent. So there we already know the triangle's isosceles. Okay, so this was given. Okay, and then the other thing is we were told that JK is parallel to XY. So now I know that JK is parallel to XY. And I guess I could do that here too. These are parallel. All right, so that was given as well. Okay, so there's the two givens out of the way. So this is an isosceles triangle. So from our givens, we know that angle L is congruent to angle K because if two sides of an isosceles triangle are congruent, their alternate base angles are congruent, or their opposite base angles, I mean. So I can now say angle K is equal to, or the measure of angle K is equal to the measure of angle L. And the reason is base angles of isosceles triangles are congruent. Okay. All right. What else do we have? Now we can say the measure of angle K is congruent to the measure of angle XLY, which is down here. The measure of angle K is equal to the measure of angle XYL. Let me see. Measure of angle K equals the measure of angle XYL, which is right here. And the reason for that is we have two parallel lines. We have a transversal. These are corresponding angles. Okay, so I'm just going to say corresponding angles are congruent. I'm being a little short here. What you could say is when you have parallel lines cut by a transversal, corresponding angles are congruent. I'm just simply stating that they're corresponding angles. So, all right, so that's that. All right, so now that means that XYL, which is right here, is congruent to L. So now we have two base angles congruent. So now I can say, well, in that case, the measure of angle XYL equals the measure of angle L. And that's transitive property. And that's from up here. If K equals L and K equals XYL, then XYL has to equal L. If they're both equal to K, they're equal to each other. And let me put an angle symbol there because it looks like MLL. Measure of angle XYL equals the measure of angle L by the transitive property. So now I have two base angles congruent, and so now I can say XY equals XL. So now I can actually state that these are congruent. Let me use two markers because they're not the same length as JK. And if two angles of a triangle are congruent, then the sides opposite are equal. Okay, since this angle is congruent to that, it makes it an isosceles triangle, therefore opposite sides are congruent. And we have proven that XY is equal to XL. Okay, this is page 3, and it brings us to proof number 5. Now, when I was setting this problem up, okay, it made me feel like I was doing one of those online question problems where it says, how many triangles do you see? So I'm going to explode this. Some parts we may use, some parts we may not, but I want to address every possible triangle that may be necessary to solve this proof, or prove this proof, I should say. So there's one triangle. Let me label it as I slide that off there. That is A, and that was vertex B, and that is C. Okay, that was this whole piece here. And I can do the same over on the other side. So then, as you can see, this is BC and then D over there. So I'll put this over here. And this is B, C, D. Okay. So then once I do that, then I still have smaller triangles like ABE. So I'll bring AB down here. This is A, that's B right here. This is A, and this is E. Okay, and then if I bring this piece down, this is another triangle. And those are vertices. This was C over here. This is E here, and this is D here. And then finally we have this one triangle here, green, down below, and that is vertex BEC, triangle BEC. So how many triangles are in this diagram? Just looking at this, you might say 3, but there's actually 5. Okay, so may use all these, may not, we'll see. Let's start with the givens. Angle 1 is congruent to angle 2. Now I'm going to label it. Angle 1, congruent to angle 2. That was that little green triangle down here. So that's this angle here and this angle here. So this was 1 and this is 2. All right, comma. Angle 3 is congruent to angle 4. Okay. Angle 3 is right here. Angle 4 is right here. Those came off of the little triangle here, ABE. And so angle B in this triangle is 3. And then DEC is the blue one here. And this would be my angle number 4 in that triangle there. Okay, reason given. Okay, so we're trying to prove AC, that's this line segment here, or side of this triangle, is congruent to BD, this triangle here. So we're trying to prove this congruent to that using this diagram. Okay. All righty, so we have an isosceles triangle down here in E. So now I can say BE is congruent to CE. Okay, BE is congruent to CE. Okay, reason. When two angles of a triangle are congruent, then it's an isosceles triangle, therefore opposite sides are congruent. Okay, that was a lengthy reason. Okay, so BE is congruent to CE because angle 1 was congruent to angle 2 in this little triangle down here. So now I can label that in my diagram here as well. That's congruent to that. Okay, so that means this is congruent to this. Following that, because they share the side, the red triangle was up against BE is BE and EC is EC. They came from the same diagram. Okay, so now we know we have an angle and a side in these two triangles. Okay, so what can we do next? Well, let's see. Oh, I see now. We have vertical angles. So looking in this diagram here, I'll use 3 marks for this. This angle is congruent to that angle because they're vertical. So that's angle AEB. So that is right here. And DEC. That's right there. So angle AEB is congruent to Let me move that down too. I'm not lined up. I don't want to run into my reason over here. So angle ABE is congruent to angle DEC. Okay? Because vertical angles are congruent. Okay, vertical angles are congruent. So now I have that triangle congruent to that triangle. So now I know AE is congruent to DE, right? What else do we know? Angle A is congruent to angle D. Let's go with that. So here's angle A. I'm using 4 now because I've already used 1. I've already used 2. I've already used 3. So now I use 4. Angle A is congruent to D. Okay, and so angle A is congruent to angle D. Corresponding angles or corresponding parts, apart an angle or side, corresponding parts of congruent triangles are congruent. So now I have 1, 2, 3, 4 arcs here. 1, 2, 3, 4. Okay, so remember we're trying to prove AC congruent to BD, and here's my diagram over here. So here's A, that's congruent to D. Okay. All right, so then what do we have? Measure of angle ABC is angle 1 plus angle 3. So we need to say that. So the measure of angle ABC equals the measure of angle 1 plus the measure of angle 3. Okay. Also, since we're doing that, we're now going to say angle DCB, the measure of angle DCB equals, DCB is here, that's angle 4 plus 2, equals the measure of angle 4 plus the measure of angle 2. Reason, angle addition. Postulate. Angle addition postulate. Okay, so in other words, if angle 1 is congruent to angle 2, which it is, and angle 3 is congruent to 4, then 1 plus 3 is congruent to 2 plus 4. So the measure of angle ABC is this, measure angle DCB is this. So now I can say the measure of angle ABC equals the measure of angle DBC. Okay, is that right? No, DCB, my fault. Got to make sure I'm doing this correctly. That was a totally different angle. DCB. Okay, so this might be hard to see. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. So 1 plus 3 is equal to 2 plus 4. These two things are the same thing. So if ABC equals this and DCB equals an equivalent, then ABC equals DCB by transitive property. Transitive property. Okay. Or you could say substitution. Either one will work. I'm leaving transitive. Okay, so now we can say, looking back here, BC is congruent to itself from here. Okay, they overlap. BC equals BC, or BC is congruent to segment BC. That is reflexive. Something equal to itself. Okay, So now I have a side and an angle and a side. All right, so what else did I have? Oh, ABC is equal to DCB. I already said that. That's this whole thing is equal to this whole thing. That in turn becomes this congruent to that. Okay, now I see what's going on. And now I can say triangle ABC is congruent to triangle DCB. Reason, S, A, or angle, angle, side. Angle, angle, side. A, S. And now I can say what we're trying to prove. AC is congruent to BD. AC is here, congruent to BD. Reason, corresponding parts of congruent triangles are congruent, or you could say corresponding sides of congruent triangles are congruent. Okay, so there we have it. Okay, and here is proof number 6. Okay, so they're asking a lot here. This proof is asking to prove two things. It's asking to prove two triangles congruent, and it's asking to prove two angles congruent. So let me highlight what we're trying to prove congruent. Okay, so again, I'm going to explode this. So first thing I'm going to do is move these off. So we're trying to prove ABD's triangle ABD is congruent to triangle ACD. So A, B, D is this triangle right here. Right here. So I'm going to move that off and I will label it. So A was over here, B is up here, and D is here. So that's ABD. We're trying to prove it's congruent to triangle ACD. ACD right here. So I'm going to bring this down. So as you can see, we already know a side's congruent. AD is congruent to itself. There's a reflexive going on. So I think of these things as I'm going through this. What are we dealing with? And there's ACD. Now I also have these two triangles highlighted, and the reason is the other thing they're asking to prove congruent is angle 5 and angle 6. And they are formed by this triangle here. So if I went all the way over to here, that would have been a rhombus. No, it wouldn't. I'm sorry. That would have been a quadrilateral because it's not a rhombus. Or if I went all the way out here, that would have been a different quadrilateral. We want to stick with triangles. So angle 6 is in triangle ADY. So I'm going to move this off and put that right here and label it before I forget. That was ADY. ADY. Now keep in mind that it came from here and it's smaller than this angle. So these are not congruent just because they're called A. These two we're going to try to prove are congruent because it says here. But this is a piece. So let me explain that a little bit better so you're not confused. If I put this back, A is formed by angle 1 and angle 3. Got it? Angle 1 and angle 3 formed this angle here. But this angle A is only angle 4, which looks like it's congruent to 3. We don't know for sure yet, but that's what we're going to try to prove. So it's a portion. This is 1 and 3, and this is just 3, if you will, because it's equal to 4, or it will be. So I move this down now, and this triangle was ADY. So A is here, D is here. Just kidding. D is over here. That is ADX, by the way. I already did ADY up here. So this green one came from here, ADX. Okay, so there's the 4 triangles we're dealing with. There are others, but those are the ones I think we're going to use to solve this, and if not, then I'll add to them. All right, let's get this started. The measure of angle 1 equals the measure of angle 2. the measure of angle 3 equals the measure of angle 4. The reason for both of these is given. Okay, and then I'm going to label my diagram. Angle 1 congruent to 2. Angle 1 didn't come from any triangles I've just created. 1 is DAB minus angle 3, but I do not have this little triangle out here formed, and I don't know if I'll use it yet or not. So I'm not going to label anything down here. Angle 1 would have been a portion of this, or it would have been the little piece up here where this side comes over here. So angle 1's over here. Angle 3 is congruent to 4. That's those angles there. Those are in my little triangle. So angle 4 was YAD. YAD is right here. So this is angle 4, and it is congruent to angle 3, which is DAX, which is here. I'll put a little 3 right there. So these angles are congruent. So now I have an angle. Okay. And so the next thing I'm going to do is say AB. Let me make it black. AB equals AC. And that is also given. Label the diagram. AB is here, equals AC. AB is here, equals AC. Okay, so we're going to have to add some stuff up here. If 3 is congruent to 4 and 1 is congruent to 2, then 1 plus 3 is congruent to 4 plus 2. Okay, we did that in the last page. So that's what we're going to do. The measure of angle 1 plus the measure of angle 3 equals the measure of angle BAD, the bad angle. Okay, the measure of angle 2 plus the measure of angle 4 equals the measure of angle 2 plus 4 is CAD. Okay, and the reason for that is angle addition. Okay, angle addition postulate. Okay, angle addition postulate says 2 plus 4 equals 1 plus 3. So now I can say the measure of angle BAD is equal to the measure of angle CAD. So BAD is actually this angle here is equal to CAD, which is this angle here. So now I have an angle and a side for my triangle, and then I can say AD is equal to itself. So AD equals AD reflexive. Wow, it's 3 o'clock. Okay, sorry about that. So AD equals AD reflexive. So that is 1, 2, 1, 2. Okay, AD equals AD because it was right here. All right, so now I can say what we're trying to prove. Triangle ABD is congruent to triangle ACD. So ABD congruent to ACD by side, angle, side. Side, angle, side. Okay? All right, so now that I've done that, what will that benefit me? Well, if you look, let me just slide this up for a moment. If I put this triangle here, I'll put it back in a moment. I'll just hit Control Z. And I put this triangle here. See how those overlap? And the angle ADY is equal in both. They're the same angle. So that's angle D. All right. So now I can say angle BDA is congruent to CDA. That's this angle here. 1, 2, 3, 1, 2, 3. Those two angles are congruent. So angle BDA is congruent to CDA. Well, how do I know that? Well, these two triangles are congruent by angle, side, angle. I'm sorry, side, angle, side. So an angle that's in a congruent triangle is congruent to its corresponding angle in the other congruent triangle. That is, corresponding parts of congruent triangles are congruent. Okay, so now I know, since this is the same down on this little triangle, boom, 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 and that's the same as this one. Okay, now I have, oh, and by the way, AD is right here and AD is right here, right, from these. So AD, so we have a side, we have an angle, we have an angle. I can now say after that, that triangle DXA is congruent to triangle, how would I want to write this? DXA, DYA. Careful how you name them, they have to correspond. D goes to D, A goes to A, obviously, and X goes to Y. All right, so why are these congruent? Angle, side, angle. And finally, I can prove measure of angle 5 is congruent to measure of angle 6. So Y is 6. X was my 5 from my original diagram up here. See that? Okay. Let me change colors on that because I don't have room really to write 4 arcs or 5 arcs. Let me just change to blue now. This is congruent to that because the triangles are already congruent by angle, side, angle. So now I can say what the proof is asking for is the measure of angle 5 is congruent to the measure of angle 6. Reason: corresponding angles of congruent triangles are congruent. Okay, and we're done. Okay, page 4 brings us to the end of lesson 26. Go to your problem set.